Hi everyone, welcome back. Lastly, we talked about the differences of this optical flow and Farneback optical flow. Also, we see the results with the default values of this Farneback optical flow, and we are gonna get into the details of these member functions today. Actually, you can check these things. There is no detailed explanation of these member functions. Also, in the code part, even we go through any of these functions in the class, there is not any kind of information according to the member functions. Okay, also before starting, maybe I need to tell that the default values are mostly working fine with these member functions. For so specific reasons, maybe you need to change these member function parameters. Okay, anyway, maybe we can back to the code part and we can continue accordingly. Actually, I didn't change anything, just I put the member functions to see the default values. What are the default values of this Farneback optical flow class? So accordingly, we are gonna change the parameters and we are gonna see the differences. First of all, maybe we can see the default values. Also, we can this is the default value result is gonna be, so I can come to our specific moment which we are generally using. Okay, this moment. So now I see the results in here also by order 0.5, for example, get pyramid scale result and continue accordingly. So we can instead of directly focusing by one by, we can directly change the parameters by one by, and we can see the results and we can talk about that. For example, this get pyramid scale, the default value is 0.5, and also since this is a scale, you cannot put the values more than 1. For example, if I try, let's say 2 at least, and it's gonna give me error or it's gonna crash. I don't know, let's try. So okay, yeah, it crashed because it's complaining since this is a scale, you cannot give more than 1. But if I give 1, then it's gonna work, I think. So let's come to our moment. Okay, even in this case it's crashing, so in any case I need to give smaller than 1. I'm just learning that one. Also, it's even not accepting the number 1 value. Let's see with 0.99. I think it should work now. Okay, now working. So I want to put the 0.99 result to the left side. Let's come to that moment. Okay, so we came to this moment, and now we can use with the default one, which is gonna be in the right side. Well, let's come to that moment again, then we can compare for that moment how the results are. Okay, so we can zoom a little bit. You see this is the 0.99 result, and the right side is, I can say, more better for this moment. Actually, we can little talk about what these parameters are doing also. Actually, this is a scale factor, and if you decrease the scale from 1 to the 0 side, which is the default one, is 0.5, by the way, just keep in mind. And in this case, we are closing to the 1, we are decreasing the accuracy, so it's gonna lose the details. But if you make it close to the 1 to the 0, it's gonna give more detailed results. Maybe in our case we are not gonna see something different because we are totally smooth background we have, and there is not many moving objects. But I can still say maybe right side still better. Maybe for our case the optimum value is 0.5. 0.5 for our case working fine. But just keep in mind making the scale factor into the 0, closer to the 0, it means it's gonna find more details, it's gonna be more accurate. In the other case, if you closer to the one side, then it's gonna be less accurate, and but computational is gonna be faster, of course. So this pyramid scale is working in this way. And the get flex, actually maybe we can try a couple of things, but okay, let's go to here. So it's not listing the flex in here, but the flex are in this one. Yeah, I checked before also. So these are some specific flex you can use. For example, this Gaussian, you can use this if your background is not really smooth. You can use this approximation, this method in your tracking algorithm. So the default get flex is, I guess it should be 0. The second parameter is 0, so it's not using any flex. But we can, let's say, we can make the flex, let's say, what was the Gaussian, 256 is the integer value, so we can put that one and we can see the result, how it looks like. Since, as I said, this is just gonna smooth the background, our background already is smooth, so I don't know, let's see. We missed that moment, sorry. Let's come to our moment. Yes, here. So I can say there is not many differences between each other, but left side may be more accurate. It's making, for our moment, it made more accurate. But as I said, if your background is smooth and kind of the environmental things is fine, do not use flex, because it's gonna increase the speed, it's gonna decrease the computation time, increasing the computation time. So if you do not need, in your case, do not use, because it's not good. Yeah, we can continue. This number of iteration is similar to the function, some functions we talk for this optical flow. The default one is 10. So for example, the expectation, this is about the iteration, so increasing the iteration, generally known as it's gonna increase the accuracy, but of course it's wrong. For example, if you also decrease the number of iteration, it's gonna computational really faster, but it's gonna give you non-accurate results. The default one is 10. Maybe we can try with 1, but also I want to measure the time. For this case, my video approximately 5 seconds. I already copied some timer calculation in here for my loop. Just copy here. So the default one was the 10. Let's maybe first of all we can measure how much time the default value take this loop, and I also need to make this wait key 1, so it's gonna break the loop. Okay, maybe we can first of all measure the time for the default value. Okay, so it finished in 6.2 seconds, but maybe this, generally for this time issue, I generally make it work for the second time, give it second chance. So still it's completing the loop in 6.2 seconds. But if I decrease the iteration time, let's say 1, my expectation is it's gonna finish so faster, because it's not 10 anymore, it's 1, so half of the time is gone, so it's more faster. But in the opposite side, if you make 100, so I'm expecting this is gonna be okay, more bigger than 6.2. You can also see from the video it's really slow. Yeah, with number 1 it's giving 3 seconds, default value 6 seconds, but the really high iteration 100 is gonna give me approximately maybe 10 seconds or 20, I don't know. So it's really slow. Let's see the result at least. Okay, it's 37 seconds, I think. Yes, 37 seconds. So this iteration about the time working in this way, but what about the accuracy? It's really accurate in, for example, let's say in number 1, or let's see with the default one again. Let's go back to our moment. Okay, here, and let's try with number 1. My expectation is accuracy is gonna be down, but we don't know for our moment. Let's see the result. Okay, you see it didn't make much difference for our moment. So in your, this is also an example in your project. For example, if it is working fine with the number of iteration 1 or 2 or 5, let's say, it's better to use 5, because you see, right, the time is decreasing half to half. So it's really better to use low values if it works. Yeah, let's try maybe 100 is really high. Let's see, try with 50. So my expectation now, the accuracy is increased, so I'm expecting to see more better results than the right one. The right one is already good, but at least it should be the similar one. Yeah, I cannot say left or right is better, but for this case, okay, right side is also, left side is good, but maybe in some cases the expectation should be left side is gonna give better result, because it's making more iteration, so giving missing result is not an option comparing to the right side. So yeah, this iteration issue also we already checked. Window size, I don't want to get into the details of this one, because this is already an optimum values. This also similar to these three functions. I don't want to get into the details, because if you change this more different than the default one, it's really changing the behavior. For example, window size is 13. It's really specific, right? Why 13, you can think, because there are some mathematical reasons in the behind. So let's try to make it 5, for example, or let's say 1, make it, and see the result, how it's changing. You see, everything is messed up, because it's always expecting you to give around to 13 results. So I really actually don't know about the details. In the previous video also we didn't know about this sigma things, sigma kind of things. So my suggestions also, do not touch these things much if you are not really familiar. These three functions are specific functions, I can say. We can jump into this get fast pyramid function. This is important, because this pyramid algorithm also, we didn't get into that function in the OpenCV library yet, but we are going to understand more clearly this function in when we came to that topic. But for this one, we can check little bit. You can understand from the name also. Maybe we can first of all, we can see the timer differences. For example, let's make this 1 again, so we can see the loop result, how much time is completing the loop. So all the get fast pyramids, by the way, the default one is 0, which is false. This is a Boolean parameter. So we can set this into the 1. So my expectation now, normally 6.2 was the default value, if you remember. Now my expectation, it should be less than 6.2, let's say 5.9. So it doesn't make much difference. The default was 6.2 and this is 5.9. This doesn't make much differences, because my video does not have high resolution. For high resolution results, the pyramid computation is increasing really high. So for high resolutions, setting this 0 and 1 makes much difference in the computation time. For lower resolution, it doesn't make many difference. You can compare also. The default one was 6.2 seconds and this is 5.9. It's not really much differences, we can say, for our lower resolution video. But on the other hand, what does this function do? Setting this into the false, which is the default one, it's gonna increase the accuracy, I can say. But in some cases, also we can check the result again for our moment. Let's make this 0. And let's come to our moment, because mostly we are comparing here. You see, you will remember the default one, it doesn't make many differences. So if in your high resolution image also is like this, so maybe you can set this into the true, which is 1. so it's gonna increase your efficiency, and computation time is gonna decrease. The last one is number of levels. The important case in this one, for low speed motions, setting this into the lower value, and for higher speed motions you need to set this into the higher value. Of course, higher value is gonna decrease the time, I mean increase the time, also computation time. We can check for this one also. The default is 5, and let's set into this one in to 1 maybe. Okay, the default was 5. Now we set it into 1. We can make wait key again 1. Let's see. So the time is coming as 5.7, which is smaller than 6.2. So lower values for low speed motions, also computationally low cost, we can say. Low speed, lower value, and low cost computationally. This is important for this one. Also in the other case, this if you set this into the, let's say 50, let's see the result of the time. So it doesn't make much difference for our case. Maybe if we make this, let's say 1000, yeah, it doesn't make much difference. The number of levels, one, it was 5.7, this is only 5.8. It doesn't make much difference in the computation side, but maybe for high resolution it's gonna make more sense. Okay, also maybe we didn't check the our moment, but let's see. I don't expect much difference even at 1, even at, okay, you see it's similar. So for our case this doesn't mean anything much also. Okay, for this video I wanted to summarize these member functions, how these are working. See you in the next videos.